Okay, so in this video we're going to ask what happens when the object is now moving on top of the loop. Okay, in the previous ones what we did was we had a loop, and as the object was moving on the inner part of the loop, and at the highest point of the loop, it was still inside the loop. Okay, but what happens when it is outside the loop? Okay, once again, what you realize is that if it's moving really fast, there is a tendency for the object to lose contact, though it may not have any contact. So we want to know with what should be the highest speed here. Now in this case it will be the highest, not the lowest, but in this case, what is the highest speed such that the object actually maintains contact with the top of the loop? And this problem should help in that sense. What is the highest speed with which it can travel such that it maintains contact with the loop? So what we'll do in this case is that we'll look at our once again we'll draw a free body diagram, okay, which is going to give us mg down. Okay, but now in this case keep in mind that the tension is pointing upward. Okay, so the tension is pointing upward, the force mg is down, and since it is, we're going to say that the top of the loop can be approximated to a circle, what we have is mv square over r, that is pointing down. So the equation now here is going to be t, or rather not t, it will be mg minus t equals mv square over r. Okay, why t? I'm sorry, it should be Fn, the contact force. Okay, now the maximum speed that it can go. Okay, so maximum v implies that Fn is becoming 0, the contact force is just becoming 0. Anything more than that, if it has a speed, any speed more than this maximum value, then obviously it is not going to maintain contact with the track. It's going to jump off the track. Okay, so the maximum speed with which it can move is now given by mg equals v max mv max square over r, and this ends up giving us v max is equal to square root of g times r. And the condition is similar, okay, if you look at the previous one where it's the inner part of the loop, but just keep in mind that in that case it is the minimum speed that it must have to complete the loop from the inside, and here this is the maximum speed with which it can travel to complete the loop. Any speed slower than this, it will definitely maintain contact, but anything more than this and it will jump off.